we're going to be learning about, kinematics. Okay, the study of motion. Study of motion. Okay. We're going to be doing one-dimensional, and then we're going to be doing two-dimensional very quickly. This class, guys, this semester is all. Last semester was all about Ohm's law. Hunter, guys. Last semester was one equation, a lot of concepts. Okay, the conceptual part was the hard part last semester. This semester, the conceptual part will be a little bit easier because it's a little more tangible. I'm still going to be pushing on the concept, but there'll be many more equations. And a lot of folks in history here that I've seen have been sort of saying, well, you know what? Hey, Mr. A, just tell me how I know when to use this equation. Which problem do I use this equation? If you approach this semester that methodology, you are going to fail. I am stating that as a fact now.
You use methodology to write her. The guys today did not.
I didn't hear
Awesome.
Okay. Thank you. Matt, thank you for the compliment. Okay. So if you approach it that way, you're gonna be in a world of hurt. Approach this in the manner that you will try to focus on understanding the concept first. Once you understand the concept, it will be obvious which equation to use. You've got to focus on that. So try not to plug and chug. Get the plug and chug mentality out of here. All right. Okay. All right. So we're going to talk about some things. We're going to go slow. It'll speed up, but I just want to make sure we cover some basics. Okay. We've got things called vectors. You guys know what vectors are?
Yes.
Okay. What is the counterpart to a vector?
Magnitude.
What? Okay, magnitude, or better called scalar. Scalar.
Distance and speed.
Okay, well, distance and speed are two different things. Okay, if distance is the scalar, what's the vector? Anyone know? It's not speed. It's what? Displacement. Okay? If speed is a scalar, what's the vector? Velocity. Okay? Acceleration, there really is no scalar name except acceleration. It's the same thing, but it's in scalar quantity. What's the difference between a scalar and a vector?
A vector has direction.
Okay. What is a scalar? A scalar is basically, and someone used the M word earlier, a magnitude. Okay. And a vector is a magnitude plus a direction. Okay. You're here in in Fort Worth, okay? Right? And I'm telling you, want to go to, and I tell you Dallas is 45 miles away. Well, that's 45 miles away. But in what direction? Right? Don't know. I got to tell you which way to go. I got to tell you to go east to get to Dallas. Okay, where J.R. Ewing lives. Okay? Anyone? J.R. Ewing? Okay. So you've got to have the direction. Okay? Everyone knows north, west, south, east. Yes? The way to remember it. I've heard never eat soggy waffles, never eat sour watermelons. I just know it because we all know which direction north and south is, but the W and E spell out we if they're done correctly. That's my way. Remember however you want. Okay? So, here's how we use this in practice. I'm going to start here, and I'm going to end here. Okay? Let me come back, actually. I'm going to start, and I'm going to move forward, and I'm going to move to the right, and I'm going to move down. Okay? And I'm going to end here. So here's my start. Here's my stop. Okay? And let's say I move 7 meters this direction, north, and I say I move 10 meters east, okay, and I move another 7 meters south, okay. What is the distance that I have traveled?
24.
Okay, I have traveled 24 meters. It's a magnitude. What is my displacement?
10 meters. 10 meters.
Everyone?
14 meters north.
10 meters.
Okay, the displacement is 10 meters to the east, okay, and I draw that vector. Oops, excuse me. Bless you. I draw the vector like this. It's a direction, it's a length with an arrow. Okay? So for a vector line, the length that represents the magnitude, and the direction is, the arrow shows in the direction it goes. Okay? This is my displacement. It's the net movement. Now, here's the thing. This net displacement, okay, is a summation of the other 3 vectors that I had. Does that make sense? So in this case, I have traveled 7 meters. Oops, hold on, let me get out of this. 7 meters north. I then traveled 10 meters east. And then I traveled negative 7 meters north, or 7 meters south.
Is that significant?
It is. You'll see this. I'm going to do it again in a different way. You'll see. The reason it's significant is because when I add it up, I have 0 meters in the north and positive 10 meters in the east. Does that make sense? So this is how you add the vectors. A more traditional mathematical and physical approach is to not use north, east, and west, but to use what?
Positive and negative.
And, okay, positive, negative what?
X and Y.
X and Y, okay? X direction, Y direction. That way you don't have to worry about north, south, and having this whole da-da-da-da. So you're really saying negative 7 meters positive in the Y direction, 10 meters positive in the X direction, negative 7 meters in the Y direction, and then 0 meters in the X direction. Does that make sense? And this is all recorded, Juliana, too, so you'll be able to go back and look at it as well.
Yeah,
No, you're good, you're good. I'm just letting you know. Okay? So, and I missed a little arrow there. So there's going to be 3 individual arrow vectors. Does that make sense? Everyone with me? Yub yub? Everyone give me yub yub. Beautiful. Okay. So, one more example. Thank you for humoring me with the yub yub. Okay. One more example. Okay. Let's say I went 2 meters, 5 meters. This distance is 2 meters. That distance is 5 meters. What's my distance that I've traveled? What's the distance that I traveled? This is just showing the length of this line. So if I start in the circle and end at the square, how much have I gone?
7 meters.
No, I've gone how far?
Oh, I see.
Because I've gone all the way around, right? Start all the way around. Yes. I can't hear. I'm assuming, yeah, but look. Shh. Shh. All right, let me give you some life lessons, guys. It's assuming that both sides are equal. If it's drawn this way and it looks equal, it is equal. And if it's not, you can yell at that person for being a really horrible communicator. Okay? But there's an assumption you'll have to make, right? When you dimension something on SolidWorks, do you dimension here and here? No, you only dimension here. It's horizontal, so you can assume that it's right.
Okay, it's not a good picture. Let's move on.
It is a good picture.
The lengths are the same. They're the same length. It
Yeah.
looks like a square, but one is supposed to be twice as
Well,
long as the other.
on my screen, it looks like a rectangle. Sorry, guys.
Yeah.
Okay. Okay. My next question is, what is the displacement? Everyone? What about the direction?
No,
Okay.
because you got it up to the same spot.
Right. It's meaningless if you end up at the same spot. Okay? Make sense? Okay. All right. Now, I start here and I end here. Okay, but this time I go. Okay? All right. This is my path. What does my displacement vector look like? How would I draw the displacement vector? From where to where? From the circle to here with an arrow. That is my displacement. I could have taken the road less traveled, okay, the longer way, or I could have taken the road more commonly traveled, the shortest line between 2 points, a straight line. Okay? So this orange is my displacement, this is my path, or my distance. Does that make sense? Okay. Bear with me, I know some of this is rudimentary, but I want to make sure we cover it. Okay. Now, okay, let's say, one more time. Oops. Let's say I start here, and I end here.
And sure, point a straight line. Your displacement is 5 meters, 345 right prior.
Okay. So where's my displacement vector?
It's a straight line, so it
Okay, good. Beautiful.
5.
Okay, and how long and what is my displacement?
5.
It's 5. The magnitude of my displacement is 5. Remember, when I say displacement, I need what? 5 meters and some sort of direction. Guys, when I say displacement, I need a direction.
But if you don't give us like a cardinal, can we just do it up as north? If you don't give us
You'll know. Okay. Shh. Okay. So northeast. If you said northeast, that's a generic direction, right? If it's 5 miles and I'm off a little angle, that's a huge That's a huge difference. I'm not going to end up at the same place. If I am trying to get to Whataburger in Denton, and you say northeast, I may not hit it. Now I may hit another Whataburger, but the angle is very important. So you can determine. You can also be a little more accurate with your communication, okay? And you can say, again, y and x. You can say, hey, you know what? There's a theta, and I'm gonna call it theta 1. Can you guys see that? So you could say, hey, my displacement is 5 meters at theta 1 degrees from y.
60.
Hold on.
And y is your vertical because you set it on a coordinate.
Y is my vertical. But here's the thing. Oops, excuse me. Okay. Oops, let me come back here. When we talk about angles, we have to have a direction for angles too. Okay? So, angles. Oops.
What are you doing? What are you making us do? No.
What does that C
What is what?
after 5 meters?
At. It's an at. It's an at symbol. I'm just saying at.
Somebody said the same thing in the last class.
Okay? So what this means, it's really not theta 1, it's really negative theta 1. So you have to be clear. Typical standard, if up is, if this direction is positive, this direction positive, this direction z positive, right hand rule, look at that, z positive this way, boom. Okay? If my angle is this way, then z is this way. Okay? But that means to go from here to here, I'm going negative theta 1 from the y. Does that make sense? Everyone clear on that? Okay? Or you could say, look, hey, you know what? Maybe it's theta 2. So, or it could be 5 meters at positive theta 2 from the x-axis. Does that make sense?
So we have to specify relative to.
Mm-hmm. Yep, you do. Because listen, I mean, it depends on what if you told me, okay, you told me to go to Mr. Price's room, you tell me to go left, go straight, go right. That's only if I'm facing this way initially. If I'm facing this way, well, left, and then I'm going the wrong way. So it's all relative, guys. It's all relative. These reference frames are all relative. Okay? So, but where do I get theta 2? I know it's, and again, this is all because we have a right triangle, right? Theta 1, theta 2 add up to 90, right? But where in this triangle is also theta 2? Where's the theta 2 in this triangle, if it exists? Right. Because of congruency, because this line and this line are parallel, this angle and this angle are the same. Remember geometry?
Yeah.
Okay. Now, yeah. Geometry, I love geometry, and I love algebra, and honestly, those are two of the biggest things I've used throughout my career, okay? I'm not a super physicist, right? It's not my goal. That wasn't what I'm doing. But the majority of work that you'll do, if you master geometry and algebra and pre-cal and a little bit of calculus, you're going to go very, very far, okay? That's better than 98, 99% of the community, okay? You can do so much with this basic stuff. So you can build houses. You can listen. All of the strength and strain calculations and how much can I bend something with a certain amount of force. All of it's geometry based. How I figure out a moment of inertia of a material. It's all geometry based. Okay. Where am I going? Okay. So we've got this, right? So how do I figure out the angles? These angles.
Sine.
Okay.
SOHCAHTOA.
SOHCAHTOA, right?
Or you could just know that it's 36.
Or you can know that it's not 36.
It's not 3690.
So not all of them.
It's not, huh?
I was saying.
It's not 3690. So double check this, right?
You actually need to use tangent if you don't know the
Okay.
Hmm?
But we do know the hypotenuse.
Okay. How do we, guys? Just make sure. How do we? Okay. How do we prove the hypotenuse mathematically? Right. So a squared plus a squared plus b squared equals c squared, where this is a, b, and c, right? Just in case you guys are all there. Everyone's done that. Yep. Okay. Shh. Okay. Yeah.
I'm kidding.
Okay. I just listen. Everyone's at a different math level. So listen. If there's something that I cover, guys, and you don't know it, and you feel too embarrassed to bring it up in class, don't worry. You feel free to bring it up in class. And if anyone says anything, I will give them the evil eye. Okay. Okay. Shh. Otherwise, come see me afterwards, and we can talk privately. I'm not passing any judgment where you guys are math-wise, but you need to not. If you don't know something, don't not bring it up. Because you need to know it. This basic stuff, everything's going to build off this stuff, okay? All right. SOHCAHTOA, right? Everyone. Does everyone know SOHCAHTOA? Does anyone want me to go through SOHCAHTOA?
Yes.
Okay, I'm going to go through SOHCAHTOA. Are you being? No, are you joking or? Okay. Well, I don't know. Listen, I'm being very serious about this. I'm happy to do it. Does anyone want me to go through it?
No.
Okay. All right. So let's quickly figure out what that angle is, guys. So let's figure out there's three ways I can do theta 1, right? Sine, cosine, and tangent, right? Quickly, guys, figure out what theta 1, theta 2 is. Go, give me what theta 1, theta 2 is. Do it. Use your calculators. Get a calculator, use your phone. Let's go. I'm gonna give you 3 minutes, guys. Let's go. Get that done. Let's go. What is it? Let's go.
If I had a calculator, I could send these.
Well, get a phone. You have a phone?
Yeah, I don't know if my phone has it.
It does. It's an iPhone.
Yeah.
Tilt it to the side. You'll get it. Once you get open calculator, tilt to the side. Ah. Get the lock off your tilt. Yes, sir. Okay, hold on a second. Yeah. It's half root 3 over 2, right? And then whatever, and 1 half, and root 3 over 2. So, so yeah, guys, what the heck is going on? What? So, what the heck's going on? I'm always going to, listen, I am, in this class, we will be doing degrees. I don't think, the only time I'll ever do radians is maybe when we do waves. Because that's a lot of sinusoidal work. But for everything we're going to be doing for mechanics is going to be degrees, because that's what we typically work in from the world of measurement. Okay. All right. So what is theta 1? How much? Theta 1 is what?
Theta 1 is that's around 53.
How much?
53.
Did anyone else get 53 degrees? It would be. Yeah, but right now we're just talking about 53 something. 53 what? 0.13 degrees. What's theta 2?
36.87.
That's right. I know that one's right. Okay, so and those two should add up to what? 90 degrees. Okay. Makes sense? Do you want me to do the math? Anyone want me to do the math? I'm sorry?
Maybe my half code is just not in radians because I was getting it wrong.
Are you in radians or degrees?
I changed it to degrees.
And then are you doing inverse sine or inverse?
I'm not sure.
Yeah.
The only thing on here that isn't
What did you get?
is sine.
Okay, Okay, so if I do tangent of theta 1 should be what? Let's do sine. Sine of theta 1 is what? Opposite over hypotenuse, right? So it's 4 over 5, right? So the inverse sine. Yeah, you guys have to do the inverse sine.
Wait, does that say 56?
53.13. Yeah. Okay. Don't forget, guys. If you have the sine of an angle equals a ratio, to get the theta, you've got to say the inverse sine of the ratio to get the angle. Okay. Does that make sense? I'm assuming I hear a lot of like, oh, we know, but and that's why I skipped over that step. But let's make sure I want to make sure we're clear on that part. Okay, and we'll do some more of this as we move along. Okay. All right. Okay. We have 5 minutes. What I want you to do is we're going to do a practice problem. Are you ready? Swag. Okay. Here we go. Are you ready?
To get started, yes. Oh my goodness.
Okay. Are you ready? Here it is. 10 meters. 20 meters. 7 meters. What I need is the distance and the displacement. I know. Guys, when I do stuff, be aware. Things will not be drawn to scale all the time, okay? I'm going to do my best, but not always. So what is the distance and displacement vector? So you guys work it out. This is your problem set, right? This is one of your problems. This is a problem per problem. Work it out, son. Guys, you need to get, listen, you need to get notes, or you need to get